All right, so let's start talking about actual modeling in with spatial data. All right, so here, I'm not going to really talk about the model too much. I'm just going to execute it, and then we'll just use it, and down the road, we'll start getting deeper into it. All right, so here, I'm going to first get the MeUse grid data set, going to define its coordinates, and I'm going to set it to be an actual grid. So I'm going to say, hey, R, treat this as a grid. Now I'm going to fit a model. I'm going to take the zinc in the data that I have, and I'm going to say, I'm going to take the log of zinc, depends on a constant. Let's go ahead and model that. So I'm saying that there are no covariates outside of latitude and longitude that are relevant to this model. Now I want to visualize that model. So once again, I'm going to use the red color palette. So I'm using red color Brewer PAL to say that I want 4 different red colors. Now I'm going to define the image. And now this is from the model, that log of zinc that depends on no covariance. Now I'm going to plot my spatial polygons, and it's an add statement. And I'm going to go ahead and plot the location of things. So let's go ahead and see what it turns out. And we get 2 titles on here. And then boom, we have what's going on. All right, so now I can see where things are more concentrated. So I'm using latitude and longitude as the only variables that connect to the concentration of zinc. And so I can see the darker red is where I have more zinc. I can see that the circles are where things were actually sampled. And good practice, this is a very good visualization, this makes the circles bigger when there is more zinc in the location. My interpretation of this is that it looks like there's more here and more here. I'm going to go ahead and guess. I don't know this for certain, but I'm going to guess that the water flows down this way, and the zinc is accumulating as it's hitting the shore. We've got less of it, and when it comes around, the zinc hits the shore, and then so zinc is being lost as the water flows, and it's depositing, in the earth. All right, so now something I'm going to want to be able to do is get actual values from my model. Now, something that I'm going to do is I'm going to make another model. Now here I'm saying that zinc does not depend on any covariates, only depends on location. So previously I have log of zinc depends on coordinates. Now I've got zinc depends on coordinates. And something that's nice is that I can just get the predicted values directly. And here I am getting the predicted values from that log model. It's just repeating things. So now let's go ahead and visualize it. All right, so to visualize it, I'm going to go ahead and use the lattice level plot. And my function formula is that the zinc depends on the coordinates, and so it's given the name. Here is my data, so I have to convert this over to a level set format. And for coloring, I want 4 bins. And so here we can see the output of our models. And so, there's, by using log or direct, there's there is a slight difference in how things are being binned. And so, it's important for us to know the difference between this, so that here we can see that log model generally has lower, the lower color is more throughout. All right, so now let's use Splot. We're going to visualize the same thing. And so now I'm just using Splot. I am visualizing the data that I have from the predictions And I've got the cuts like I have previously, and I specify the colors. And so notice that 4 cuts results in 5 colors. 1, 2, 3, 4, 5. While up here, I've got 1, 2, 3, 4, and 5. All right, so either way, I've got 4 cuts results in 5 different colors. All right, so now what I want to do on this next one, I want to look at multiple data columns with the same visualization, with one visualization, but I want to keep it like coherent so I can check out what's going on. So I'm going to take multiple columns of data and I'm going to plot them side by side so I can see what's going on. All right, so here you'll notice I put the object is MeUse 1 through 4. All right, that specifies the data that I want plotted. And I'm using cuts just like I did before. So here I'm specifying what the cuts are manually. Now, something that's unfortunate about this is that these cuts, if I have different measurement scales, or the amount varies quite a bit in the range, I'm stuck to just one cut vector for this. But then I could just make separate plots if it's a big deal. So here we can see throughout that cadmium is low throughout, zinc is high, comparatively to the others, lead is in the middle, and copper is less than lead. Okay, so like the toxicity of each of these is different. And also I can't really tell where is it more concentrated. Here everything's so light, I don't know where is it more concentrated, less concentrated. I don't have subject matter knowledge about cadmium to know, is this a lot, is this a little for cadmium? Because it might be that a very little of something very, very toxic could be that can be very, very bad, while if something that's not toxic, having a lot of it isn't a big deal. So it's hard to interpret what's going on without subject matter knowledge. So what I'm going to do is I'm going to plot it where I rescale what's going on. I'm going to do center scale, so subtract the mean and then go through and divide by standard deviation. So I'm using the scale function to do a location scale transform of each of these metal columns. And now when I plot it, I can see where are things more concentrated, where are they less concentrated, and you'll notice that it looks in a lot of ways consistent over all 4, and it's consistent with that plot that we looked at previously, so where I have the hypothesis about the river. Now we can plot contour lines. Now here, contour lines may or may not count towards elevation. They could also be part of like a modeled values for what's going on. But usually when I say contour, I'm going to be talking about elevation, but there's no reason to not generalize this to functions in general, where I have like z depends on x, y, and possibly other variables. All right, so I'm going to define my color scheme of red. I'm going to take the MeUse grid once again, and I'm going to convert the grid to a spatial pixel data frame. Now to get the actual contour lines, I'm going to use the contour lines to spatial lines data frame in map tools. Now to be able to do this, I have to specify what I have as contour lines. So I have to take the contour lines that are being defined by MeUse grid dist, which I'm going to set up as a spatial grid data frame, and then I pass that to the contour lines. And so now we can see where is the elevation. So we can see that where the river is the lowest elevation, and up here it looks like there's a hill, but we don't have a complete data set for this because it wasn't relevant for sampling. Now something I really don't like about this is that we have a gradient of the elevation, but it goes and then it restarts itself. So it takes a moment to figure out what's going on. You have to know where is it low, where is it high. It's better to have like the actual numbers on here for our contour plot. All right, so another option I have is to go through and do the plot, do the contours, but an entire region is going to be colored the same color. And so instead of having the lines be colored, I'll have the space basically between the lines colored. So I'm going to use the SP plot function. Once again, I'm grabbing my grid. Now, distance is the variable that I'm interested for determining the colors on it. And I'm going to specify the cuts as being where I'm going to break it up. And so here is another way to see that lower elevation, a little bit higher elevation, higher than that, and then here is going to be like the peak of a hill. All right, next I want to plot regions by data bins. So what I'm going to do, I'm going to take my numeric data and I'm going to bin the data, and then I'm going to color by those bins. So what I'm doing here is I'm specifying the frequency in terms of category or ordinal data, and then I just put this frequency as my Z column. And here we get a more nuanced look at what's going on for the frequency. So this is low color, the light color is annually, 2 to 5 years is the middle color, and then greater than 5 years is the dark red. Now here is another way to go through and get contour, and I like this more than the previous one because I have one continuous transition of colors. I'll have to figure out where it's high, where it's low, which can be a problem. Dark is low, yellow is high up. All right, and to do this, once again, I have to get my grid to be a spatial pixels data frame. And then I'm going to convert it to the image of a spatial grid data frame. Then I get the contour lines to a spatial lines data frame, and then I just plot it. So once it's in a spatial lines data frame, boom, I get my contour plots. So all this work here was just to get this bit of code. Now, something else I can do, I can start taking more control over what's going on. I can define the layout. I can, and put down arrows. I can rescale things. And so what I can do here, I'll show you the outputs, is that I can start controlling things like putting down the scale, putting down the arrow. I can, define my color bar. And that's what I'm doing here. So I have the river object, and then this is what's going to define the north arrow for me. This defines that scale bar. These are the labels of the scale bar. Now this is for plotting the points on after I have everything else down. Now, what we're going to do for the layout, now here, this is important, is that this is an ordered list. So I have the polygon, I have the north arrow, I have scale on here, and then I have the numbers for the scale, and then I have the points. So the order in which this is put down from the early ones are the ones that are put down first, and then the other items are stacked on top. So this gives me control over stacking things on top of each other. Now here I'm defining my colors, and then I'm going to go ahead and plot my log model. Now this is the predicted values, but I'm going to specify that I want this layout for it. So what's happening is that this along with this, so the model plus the color palette determines the colors and the pixels, and then the layout determines that the river is here. It determines the north arrow, the scale, and gives me this information. Now we can also use Gplot. All right, so Gplot is definitely a good way to create things. Just that we have to make sure that the data I have is in the format of a data frame. So what we can do, I use the as function to convert to a data frame. I personally would use as.data.frame, but this is definitely a good way to go. This is the as function is very flexible. Now what I'm doing here, this cut function, is I'm saying I want to bin my points together so that it's a little bit easier to set up the coloring. And then just like regular old Gplot, I specify what the data is. I specify the aesthetics. So here, X and Y are the coordinates. The color is the bin of the zinc. I'm plotting the points. I'm making sure that my coordinates are equal. If I don't do this, it's going to stretch out the axes to fill the plot region that I have. Well, here that doesn't make sense. I don't want that distortion. I want the coordinates to be equal. And here I'm just saying, hey, the colors need to come from the Brewer-Powell reds object. And I recommend using theme black and white for most problems, by the way. Now we can also use the last extra package. All right, so this part is similar to what we've been doing so far, or this is regular. Notice I have a P here. So I'm specifying that this plot is a P. I'm specifying that this is an M. Notice that I've got spatial polygons data frame for M. And here I have for L is another plot. And so now what I'm going to do is I'm going to print L plus P. So here, my spatial polygons data frame is inside this plot here. And so I go P plus L in the print. It's going to give me my plots. So this one is zooming in, while this one gives me a more complete picture of the river. Now, something I can also do is I can color points by quantile bins. All right, so here I'm just specifying my color ramp palette, going from red to white. Now, if I want to go through and bin things by quantile, I can use the class int package, use class intervals. I'm saying that I want to use zinc to determine what the quantiles are, and I want 5 bins. And so boom, we can see I get 5 bins, 1, 2, 3, 4, and 5, and they're all with an equal number of observations, approximately. So quantile will give me approximately the same every time. Now here, remember, if I'm using quantiles, I probably will not get constant interval width. If I want constant interval width, this is not the way to go for quantile. I want to change the style to interval. And so now I can check and see that each of these sub-intervals has the same number of points in them, but here things are a lot more spread out. So this kind of shows that we've got some skewness going in our zinc data. Now I can do the same thing, but now I'm going to bin my data by the Fisher-Jenks algorithm. And so what I change here is that I change the style to Fisher when I call class int class intervals. So the big change is just the Fisher for the style. And so now we can see that I have different widths for the intervals, and I have a different number of points in each bin. And so now when I plot it, we can see that here, this one is not so compressed. It's kind of like, so the Fisher one is a good compromise between quantiles and constant intervals. Now, something I can also do is I can use the find colors function to specify colors in other plotting formats. And so here, I'm figuring out what the colors are for my quantiles and my palette. And now I'm using the find colors to figure out what it should be. And I just pass that to my plot function. And so now I can see that. And I can do the same thing with Fisher. This should say Fisher. It's a mistake. All right, and so now I've got the points in that manner. And I can also control the plot character. So you'll notice I've got a dark circle around each point. Now, I may or may not want that. When I start getting a lot of data, when things start like overlapping, the dark circles can make it harder to see things, or it might make it easier to distinguish between things. It goes both ways depending on my data. So here, what I can do is I can control my plot character by just saying I want the plot character to be something different. And so here 19 is just a plain dot, no outline on it. I can also take control of the cuts for my contour plots by just specifying what the cuts are going to be with a vector. So here we can see the elevation. I don't really like these colors for the purpose, but the information is correct. Now the rest of the code is involved with interactive plots. And now this video, I'm using an R Markdown HTML document. So I'm not really doing the whole click on things to see which point is which. If I was going to do interactive, honestly, I would be using Plotly. I would not be using the base R interactive tools, but they're still available. They're there. You can use them. Here are some examples for you to be able to take advantage of. Well, that's all I've got for you. Take care and goodbye.